Hi, this is the continuation of the polar review. So we're going to do some converting between polars and rectangulars, points and equations, and we're going to do a little bit of calculus at the very end. So just as a refresher, we have these formulas, and I don't know if you remember these, but if we were on the coordinate plane and we drew a circle, whether it was a unit circle or just any one of the polar graph circles, we would have this situation. This would be the radius of my circle, would be basically the hypotenuse of my triangle, and the bottom is the x-coordinate in rectangular form, and this would be the y-coordinate in rectangular form to plot the point that I've somewhat identified. So from this is where all of these other things come from. So let's go ahead and start with our Pythagorean theorem. So from here, we would know that x squared plus y squared is equal to r squared. That's just Pythagorean theorem. So that's what gives us this formula right here, that r is going to be the square root of x squared plus y squared. Again, if I look at having a theta, that's where my theta would be if I were looking at my polar graph. Now I can start talking about trig. So if I did the sine of theta, that would be opposite, which is y, over hypotenuse, which is r, at which point I can solve for y, and I get r sine theta is equal to y. So that's where this one comes from. Same idea when I go to use cosine. Cosine of theta is going to be x over r. To get x by itself, I multiply both sides by r, and I get x equals r cosine theta, which is where this comes from. And then if you were to look at that triangle, you would know tangent of theta would be y over x, which is this one. So that one should make sense as well. And again, these are ones that you need to know, so either do what I just did to come up with them when you start an assessment, or just have these memorized, whichever you prefer. So let's go ahead to 11, and we're going to convert this into rectangular coordinates. So starting out, the first is my r, so I know my radius is 2. The second is my theta, which is 5 pi over 6. And so from here, I'm going to need to convert this thing into x's and y's. So I have these options above: x equals r cosine theta, y equals r sine theta, r equals the square root of x squared plus y squared, tangent of theta equals y over x. So I've got to pick which I want to do. Now in this one, when I have r and theta, the easiest to use are these two, where x is very spelled out and y is very spelled out, because that's what I'm trying to find, is an x-coordinate and a y-coordinate. So x is going to be r cosine theta, which means x in this case is going to be 2 cosine of 5 pi over 6. And again, we need to know our unit circle trig, and you need to know what cosine of 5 pi over 6 is. If in any case, you need to know the cosine of pi over 6, which is square root of 3 over 2, and 5 pi over 6 places it where cosine is negative. So this is going to be 2 times negative square root of 3 over 2, which when I simplify that is negative square root of 3. So that's my x-coordinate. My x-coordinate is negative square root of 3. Now I need to find the y-coordinate. So y is going to be r sine theta, and so y is going to be 2 sine of 5 pi over 6. And again, we need to know the sine of 5 pi over 6 or the sine of pi over 6. And note that sine will be positive where 5 pi over 6 falls. So I have 2 times 1/2, and y is going to be 1. So the y-coordinate is 1. And this is that polar coordinate turned into rectangular coordinates. So for number 12, we're going to convert 3, negative 3 into polar. So now we're going backwards. We have x and we have y, and we're trying to find r, and we're trying to find theta. So to do this, I would go ahead and I would use the same idea that we just used, except because I've got x and y, I would start by finding the radius. So I know the radius is going to be x squared plus y squared and the square root of that. but I have x and I have y. So let's go ahead and figure out what that is. I have 3 squared plus negative 3 squared. So I'm taking the square root of 9 plus 9, which is the square root of 18. Simplest radical form, 3 square root 2. So that's what my radius is. I found r. So that's the first part of my point, is r, 3 square root 2. Next, I need to find theta. So now that I know what r is, I should be able to use that to find theta. So I'm going to go ahead and use the x formula. So x is going to be r cosine theta. And I know what x is. X is 3. I know what r is. It's 3 square root 2. And I'm trying to find cosine of theta. So I divide both sides. And so I have 3 divided by 3 square root 2 is cosine theta, which means cosine theta is 1 over square root of 2, which isn't a form that I really recognize. So that really means that cosine theta is square root of 2 over 2 by rationalizing the denominator. At this point, I should know what angle, when I take the cosine of it, gives me square root of 2 over 2. So that tells me that theta is pi over 4. But there should be another one. So cosine is positive in the 4th quadrant as well. So that means we also have 7 pi over 4. Both of those thetas will work, which is why now I need to use my y formula to narrow down which one this is. So y equals r sine theta. So negative 3 is equal to 3 square root of 2 sine theta. And I hope I don't have to go through all that again, but I know that this is negative square root of 2 over 2 is equal to sine of theta. So I know I have a 45-degree angle, pi over 4, except that sine is not negative when I use pi over 4. Sine is negative when I use, let's see, I need to be in the 3rd quadrant or the 4th quadrant, which means I need 5 pi over 4, and I need 7 pi over 4. At this point, I think you should be able to tell what our theta is. It's the one that works in both the x equation and the y equation, which is 7 pi over 4. So now I can write my point, which would be 3 square root 2 for r and 7 pi over 4 for my theta. That is that point converted into polar. Next, we're going to convert some equations. So, y is equal to 4 is the first equation we're going to convert. So right now this is in rectangular form. If I were to sketch what this looks like, y equals 4 would just be a line up here, y equals 4. So now I need to write, well, what is that going to look like in polar? So, okay, polar is going to have an r in it and a theta in it. So I know that y is equal to r sine theta. Well, I know what y is in this case, and it's 4. So 4 is equal to r sine theta. That is the equation in polar form. So typically when we're in Cartesian form, we have x's and y's. In this case, we only had y, but I could have just y, just x, or x's and y's together. So in my polar form, I can have just r's, just thetas, or r's and thetas together. So here we go with a polar equation. Now this equation is going to be just like the Cartesian form, y equals 4. So even if I graph it where I'm on a polar grid, it would look like this. But I would get the same graph. So moving on to part B. This one, x squared plus y squared equals 25. First of all, we should know that that's a circle centered at the origin. The radius is 5, so we know what that looks like in Cartesian. And what I'm going to use is that we know that in polar, we know x squared plus y squared is going to be equal to the radius squared. Okay, well, ours says x squared plus y squared equals 25, which means my radius has to be 5. So again, if I were to graph that on a polar grid or on a rectangular grid, I would have 1, 2, 3, 4, and this graph would look like this. r equals 5. So whether I'm on the Cartesian plane or the polar grid, I still get the same graph. Number 14. This one has, I feel like this one's a little trickier, a little more difficult, but we can do it anyway. So we're going to convert the following equations to rectangular form and then sketch the graph based on the rectangular equation. So in this first one, r sine theta, I should immediately recognize r sine theta. And r sine theta is equal to y. Y is equal to r sine theta. But I know that in this case, r sine theta is equal to 3, which tells me y is equal to 3, which means I have a vertical line at y equals 3. There's my graph. Not too bad. So then we look at the next one, and it looks so close to the x equation, but it's really just not, because it should be x equals r times cosine theta, and that is exactly not what we have. So I actually have to do a little bit of work here. So I'm going to go ahead and divide by 2. So r divided by 2 is cosine theta. So now I know what cosine theta is. And if I take my formula for x, I know that x is equal to r cosine theta. But the key here is that cosine theta will be equal in both equations. So if I take this and I take x divided by r is cosine theta, then I know that x over r and r over 2 have to be equal because they're both equal to cosine theta. So r over 2 is equal to x over r, I cross multiply, and I get 2x is equal to r squared, which is handy because now I have an x involved, but it's unfortunate because I have an r involved. But I like seeing r squared because I know what r squared is. By Pythagorean theorem again, x squared plus y squared is equal to r squared. So wherever I see an wherever I see an r squared, I can plug in x squared plus y squared. We're going to have a little bit of work to do, so I don't know if we're going to fit it all right here. I'm going to go down below the graph for right now. So at this point, I have 2x is equal to my Pythagorean theorem, x squared plus y squared. So right now, that doesn't look too happy. Is this a parabola? Is this not? What is this thing? Well, the fact that I have a x squared and I have a y squared and I'm adding them tells me it should be a circle. I guess technically it could be an ellipse, but it's going to be a circle. Okay, what we get to do is we get to complete the square to get our equation of a circle. So let's refresh on that. I'm going to bring the 2x to the other side. So I have x squared plus 2x, leave a blank, and then I have plus y squared. And the blank, what I'm going to put in there is I'm going to take that 2, this 2, divide by 2, and I'm going to square it. And 2 divided by 2 squared is a 1, which means I put a 1 here, but I also got to add a 1 to the other side. So my equation is 1 is equal to x, let's factor this, x squared plus 2x plus 1 should be x plus 1 squared, if we completed the square correctly, hopefully. And now you should be able to see that we have a circle. The center is at -1, 0, and the radius is 1, or the square root of 1, which is 1. So now I should be able to graph this equation. Again, my center is at -1, 0. It's my center, and my circle has a radius of 1. So I should have a shape, well, it should be a circle. That's not. Your graph should be a circle. Sorry about that. Okay, now we're moving on to part C. Now this one we have theta is 2 pi over 3. So I know theta, but I don't know anything about r. So look back at your equations and find one that just has a theta in it but doesn't have an r. And when I look back, I'm happy to find tangent. So I have tangent of theta is equal to y over x. So let's plug that in. I have tangent of 2 pi over 3 is equal to y over x. So now I need to know what the tangent of pi over 3 is. And the tangent of pi over 3 is the square root of 3. And now I need to put it in the correct quadrant. At 2 pi over 3, the tangent is negative. So this gives me negative square root of 3 is equal to y over x. So here I'm just going to get y by itself because it looks like it's a linear. Y is equal to negative square root of 3 times x, which is a linear, and it's something along the lines of this. should go through the origin. Should go through the origin. Use a ruler. And so it's about there. I'm not really going to estimate that slope specifically. So that is converting between parametric and polar and rectangular and polar. So moving on to the next one, number 15. Number 15 wants us to use our grapher in polar mode so that we can graph this thing. So let's get your calculator. Sorry, I didn't tell you to get the calculator. Pause the video if you don't have your calculator, because you got to practice putting this stuff in polar into your calculator. So here, first thing we need to make sure that our mode is in radian, or we're going to get all kinds of silly things. So we're in radian. Y equals is not what I want to see. I want to see that we are in R equals theta mode. So we're going to go back to mode again. And if you see down there after the radian in degrees, we've got function. The next one is parametric. The next one is polar, even though it just says pole. So hit enter on pole to change our graph to be polar. And y equals, we now have an r equals, which is exactly what we would want to have. So with our r equals, we're going to plug in 1 minus cosine theta. And if you just use that variable button, x, theta, t, n button, it should work. And let's go ahead and look at our graph. Now, my graph isn't very pretty. First of all, I don't like the window. So I'm going to go ahead and pick zoom, and let's do decimal. Zoom decimal works pretty well with your polars. It's trying to make a square window. And you can kind of see there's what's called a dimple on the right side. This is a Limason graph, which we'll get into the names of the graphs. So let's go ahead and just give it a little sketch. My sketch is going to be terrible. Yours should be better. Basically, we have something that looks like this. So it might be a cardioid, but I think it's a Limason. No, it is a cardioid. Sorry, it is a cardioid. Cardioid, that means that this is a pretty deep indentation right here. And we'll get into why this is a cardioid a different day. So number 16. So now we're going to think of this as a parametric curve. So we're going to turn this now into a parametric equation, which means in a parametric equation, I'm going to write down here, I'm going to erase it. We would have y equals blah, 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 blah with t's. We could have t squared plus 5t minus 1 or something. And then we'll have x's terms of t as well. And we'll graph these simultaneously. While picking t as 1, we plug 1 into both the y equation and into the x equation to get a point. We plot that point. So that's the basics of what a parametric equation is doing. So the first thing we need to do is get this in parametric form. So we know, sorry, I'm gonna write this up by my graph. So we know that r is 1 minus cosine of theta. And we also know what x is. X is r cosine of theta. So all I'm going to do is I'm going to take this r and I'm going to plug it right in right here. So instead of the example I showed, the variable for y and x was t, the variable for this one is going to be theta. So we're going to have x equals 1 minus cosine theta, plugging that in for r, times cosine theta, which is just still there. We're going to do the same thing with our y equation. Y is equal to r sine theta, and so y is going to be equal to 1 minus cosine theta times sine theta. So here we have this equation, this polar equation, written now in parametrics. So let's go ahead and now graph it in our grapher again. So go back to mode, and we need to put us in parametric instead of polar. And now when we go to y equals, you'll see that for each line that's there, we have an x1 and a y1. So I'm just going to plug in x1, parentheses, 1 minus cosine theta. And then we're going to do times cosine theta. Oops, I lost a parenthesis. Apologize, you need a second parenthesis right there. So that's my x, and then I'm going to plug in my y. 1 minus cosine theta again. I'm going to remember my parenthesis this time. And then times sine theta. So once we've got this, we're going to go ahead and hit graph again. And we get the exact same graph we had, this little cardioid graph. So next thing we're going to do is our little bit of calculus. So for our calculus, I'm going to need this x and this y written down, and I'm actually going to distribute my cosine or my sine through. So for my x, I'm going to rewrite that as cosine theta minus cosine theta quantity squared, because I want in calculus friendly terms. And then for my y is going to be sine theta minus cosine theta times sine theta. So I do have a product rule right there, but I don't have a product rule every time. So we're now going to find dy dx. All that really means is we're going to find dy d theta, because y is in terms of theta. We're also going to find dx d theta. And when we divide dy d theta by dx d theta, that's going to give us dy over dx. We okay with that? Not? Bring some questions to class. But this is essentially what we're going to do. We're going to find dy d theta, we're going to find dx d theta, we're going to divide them. It's going to be a mess, but it's going to be fun. We can do this. Okay, so let's go ahead right now and find dy d theta. So dy d theta is going to be cosine theta minus the product rule again, a bit of a mess. Let's go ahead and simplify a little bit by distributing our negative and making things squared. So we have negative cosine squared theta, and then we have a positive sine squared theta. As much as I wanted that to become a 1, it doesn't. We'll do the same thing with our x. So dx d theta is going to be negative sine theta minus 2 cosine theta times negative sine theta. And I don't know if there's really anything we can do about that. So we're going to go ahead and write now what our dy dx is. And we have cosine theta minus cosine squared theta plus sine squared theta all over our blue negative sine theta minus 2 cosine, sorry, plus 2 cosine theta sine theta. That is our dy dx. That's our calculus. So moving on to 18, we're going to use this to find the slope of the curve, the polar curve, at the point corresponding to theta being pi over 2. So all we do now is we plug in pi over 2 into our equation. So we have cosine of pi over 2 minus cosine squared pi over 2. Hold on, let's see if my computer will catch up. I'm trying that all over again. Okay, so dy dx at pi over 2 is going to be equal to cosine pi over 2 minus cosine squared pi over 2 plus sine squared pi over 2 all over negative sine pi over 2 plus 2 cosine theta pi over 2, excuse me, sine pi over 2. So we need to get a couple things straight. We need to know the sine of pi over 2, and we need to know the cosine of pi over 2. So the sine of pi over 2 is, you know it, write it down. It's 1. The cosine of pi over 2, do you know it, write it down. It's 0. Okay, so let's plug all this stuff in. So cosine pi over 2, 0 minus 0 squared plus 1 squared all over negative 1 plus 2 times 0 times 1, which is 1 over negative 1, which is negative 1. So the slope of the curve at theta equals pi over 2 is negative 1. Okay, so that is the rest of the polar review with a little calculus involved. So we'll work some more on polars when we get into class, and I hope you have a wonderful evening.